So the next step on our story of protein synthesis in eukaryotes is the process of translation. Translation is when you start with messenger RNA and you turn it into proteins. And if we think about the subunits for both of these pieces, that means that we're starting with nucleotides that are a part of an RNA molecule. Those nucleotides are then being transformed into a string of amino acids, because that's what makes up a protein. And all of this is going to happen with transfer RNA that are going to come together with the messenger RNA and the string of amino acids at a ribosome. When we describe translation, we're going to start with a molecule of messenger RNA. And that strand of messenger RNA has got bases on top of it. And so I'll just give some bases here to get us started, just so we have an example. And that string of nucleotide bases is always going to begin with the sequence AUG. AUG is the start codon, and it always lets us know that we're at the beginning of a gene. So that messenger RNA is going to bind to a ribosome. And ribosomes have two subunits. That's why we've got a bottom piece and a top piece. And this ribosome has three sites, which are the E site, the P site, and the A site. So different things happen in each of these three spots on the ribosome. The A site is called the A site because it's like the first site that's going to be used. It's the very first one, so we say that it is the A site. And a transfer RNA is going to attach to the A site, and it will be carrying the very first amino acid within this sequence. Now that we've got that first site taken care of, our messenger RNA is going to stay where it has already been, but instead the ribosome is going to move. And so the AUG, which used to be at the A site, that is now going to become a part of what we call the P site, which is the second site within the ribosome. So we're just redrawing our picture so that we can kind of not try to squish everything all into one image here. And so AUG is now at the P site, and our next codon, or string of three nucleotides, is CCC. So as the ribosome moves along this piece of messenger RNA, the transfer RNA is going to be stationary. That same transfer RNA that used to be bound to the AUG, that is still bound to the AUG. And it is at this P site. Now we bring in a new transfer RNA, which is carrying that second amino acid. It's at the A site. And since amino acid number 1 is so close to amino acid number 2, we form what is called a peptide bond in between amino acid number 1 and amino acid number 2. And that's why we have the P site as the P site. P site is where we're going to form a peptide bond. So now amino acid number 1 is joined to amino acid number 2. Amino acid number 2 is joined to a transfer RNA at the A site where we have the codon CCC. For the third step, we're going to do like we did before. Now everything's going to slide over to the right. The entire ribosome is going to move from the left to the right. And so the AUG is now at the E site. Our CCC is now going to be at the P site. And that next codon, which is GGG, that's going to now be at the A site. And so now that our amino acid number 1 is joined to our amino acid number 2, when we put in this third transfer RNA that is carrying amino acid number 3, and a bond, peptide bond, just like before, joins in between amino acid number 2 and amino acid number 3, you'll notice that the transfer RNA at the E position, or that very first one, nothing's really holding it anymore. And so it's just going to leave. And that is the function of the E site. The E site is the last one, stands for exit. And now we're just going to repeat the entire process until we move along to the end of the gene. So if we kind of view out, kind of imagine that we're zooming out from this view, and you think about the entire molecule of messenger RNA, that entire molecule of messenger RNA is going to have a whole bunch of ribosomes attached to it. And each of those ribosomes has got these E sites, P sites, and A sites. And each of these ribosomes is going to be zipping along that piece of messenger RNA and creating a polypeptide chain behind it. And that polypeptide chain is going to start to fold and become mature. And when the messenger RNA gets to the end of that strand, the ribosome gets to the end of the messenger RNA, it's just going to fall off. It's going to get to the termination sequence. The two pieces are going to separate. Our polypeptide chain is going to attach, it's going to fold and become that mature protein, which could go on to become an enzyme or do whatever it is it's going to do. And so we're going to simultaneously have several ribosomes zipping along this piece of messenger RNA. The polypeptide chains that we see as we move towards the 3' end are going to be smaller because they're earlier on in the manufacturing of that mature protein. But it's the same process. And so we're just bringing in new codons at the A site, creating peptide bonds at the P site, and then transfer RNAs are leaving at the E site. And this entire process is repeating until we finally get to the end with that very last codon. And these transfer RNAs can be recycled. They'll go out, find another amino acid, and bring it into the same position just like we saw in the beginning.